Alright, so in this short video, I'm gonna be explaining an important article which has the title of "Don't Stop Pre-Training, Adapt Language Models to Domains and Tasks." So this article in 2020. Language models pre-trained on text from a wide variety of sources form the foundation of today's NLP. In light of success of these broad coverage models, we investigate whether it is still helpful to tailor a pre-trained model to the domain of a target task. We present a study across 4 domains: biomedical and computer science publications, news and reviews, and 8 classification tasks, showing that the second phase of pre-training in domain, which is domain adaptive pre-training, leads to performance gains under both high and low resource settings. Moreover, adapting to the task's unlabeled data, task adaptive pre-training, improves performance even after domain adaptive pre-training. Finally, we show that adapting to a task corpus argumented using simple data selection strategies is an effective alternative, especially when sources for domain adaptive pre-training might be unavailable. Overall, we consistently find that multi-phase adaptive pre-training offers large gains in task performance. So this is an illustration of data distribution. Task data is comprised of an observed task distribution, usually non-randomly sampled from a wider distribution, which is light gray ellipses, within an even larger target domain, which is not necessarily one of the domains included in the original. This is the original pre-training domain, though overlap is possible. We explored the benefits of continued pre-training on data from the task distribution and the domain distribution. So we have original large LM domain, and we have target domain. And here is the intersection, which is the task that we are working, so that it could be a fair comparison. So domain adaptive pre-training. Our approach to domain adaptive pre-training is straightforward. We continue pre-training in Roberta, a large corpus of unlabeled domain-specific text. The 4 domains we focus on are biomedical papers, computer science papers. Sometimes we have these domains explicitly, like different source data sets. But sometimes you don't have those domains explicitly, so you should run some algorithm like Gaussian mixture models to obtain those domains, or any other clustering approach like k-means, or even a combination of k-means and Gaussian mixture models. So, this procedure is called domain discovery. But this paper is not using it. It's just saying that we already have our domains. There are different data sets, one of them biomedical papers, the other one news text, the other one reviews. And so these are different domains. But it's a naive approach. The best approach is to use this domain discovery so that it has better contextual representation in the context of domains. So analyzing domain similarity. Before performing this DAPT, we attempt to quantify the similarity of target domain to Roberta's pre-training domain. We consider domain vocabularies containing top 10K most frequent unigrams. incomparably sized random samples of held-out documents in each domain's corpus. We use 50K held-out documents for each document other than reviews, and 150K held-out document in reviews since they are much shorter. We also sample 50K documents from source similar to Roberta's pre-training corpus, like Wikipedia and stories and real news, to construct the pre-training domain vocabulary since the original pre-training corpus is not released. So the next figure shows the vocabulary overlap across these samples. We observe that Roberta's pre-training domains has strong vocabulary overlap with news and reviews. So these are different domains: domain 1, domain 2, domain 3, domain 4, domain 5. And we repeat it here: domain 1, 2, 3, 4, 5. You see the overlap between them, and we observe that the overlap of news and reviews, Roberta's pre-trainings, has a high pre-training. These are pre-training, and they have high overlap, as you see. So this is an example that illustrates how some domains might have overlaps with others, leading to unexpected positive transfer. We highlight expressions in the reviews that are also found in real news articles. So there are some overlap. But task adaptive pre-training, this one refers to pre-training on the unlabeled training set for a given task. Prior work has shown its effectiveness. Compared to domain adaptive pre-training, the task adaptive approach strikes a different trade-off. It uses a far smaller pre-training corpus, but one that is much more task relevant. This makes TAPT much less expensive to run than this DAPT. And the experiments similar to DAPT, task adaptive pre-training, consists of second phase of pre-training Roberta, but only on the available task-specific train data. In contrast to DAPT, which we train for 12,000 steps, we perform TAP for just 100 epochs.